Hi, Robert Ford. I'm an IT instructor, School of Information Technology at College of the North Atlantic in Qatar. Okay. One of the courses, I teach several courses, mostly to do with programming.
Okay.
I am currently teaching the Introduction to Java Programming, and in a way to help get the students into the idea of programming, we've introduced the use of LEGO Mindstorm robots as a computer preparatory program. Okay, so this is one of the robots. We actually have the students spend 1 or 2 classes at the beginning and actually build the robot from scratch. Even if the robot is partially assembled, sometimes the students will have made some modifications. This is a fully constructed robot with pretty much all the parts that come in the educational kit. So the main body of the robot is what we call the NXT brick. So this robot is produced by Lego. Okay. And of course, this is the main brains of the operation. So inside the brick, you'll find it's a small 32-bit microprocessor. There's some RAM, I'm not sure how much, and there's also some flash storage.
Okay.
It is very simple. It's an embedded device, and it works in a way that you program on the PC, you download your programs into the brick, and then you select the program to run from the actual user interface here. Okay. Now, there are several inputs and outputs that are available with the robot. This particular robot supports a total of 3 outputs, and they're labeled A, B, C. Okay. And you'll see that there's only 2 of them that are connected right now, and that's because somebody has incorrectly connected one of my wires here. But the two things that are connected for outputs are the B and C motors, and if you follow the wires down, you'll see that these are actually connected to the main driving motors. So you'll see a standard configuration that we have our students build involves a tail dragger configuration where there are 2 main driving motors plus the tail motor which can spin. And by having full independent control of the 2 wheels, we can have the robot move forward, move backwards, or spin on the spot, or make some slower turns if required. Now, I see here there's been a small modification. Somebody has taken this motor here, which is on this arm. This should really be plugged in up here on,
at the back.
on the top as motor control A. So what we can ask the robot to do is we could have the robot go up and find something and actually take a swing. So maybe if it wants to play golf or some other sport, it could do something like that.
So it doesn't just move in a straight line, or it doesn't just move on a flat surface. It can also do some actions.
Oh, of course, yeah.
Okay.
So it just requires the extra motors to do this.
Okay.
Unfortunately, there is only a total of 3 outputs. So if there's additional things required, you would actually have to take several of these robots and hook them together. That is possible, but that starts becoming a little bit more difficult. Now, in order to interact with the surroundings, there are a bunch of input values or sensors that can be attached to the robot. There are 4 types of sensors actually. I'm missing one type here that come with the basic kit. Although there are additional sensors that you can also buy on top of these, and I'll try to remember to explain these in a second. But these are the ones that come with it. The one that I find is the most accurate and most predictable is what appears to be a pair of eyes at the top. This is actually an ultrasonic sensor, and it works the same way that sonar works. A small pulse is sent out, and it measures how far away certain objects are. This one turns out to be very, very useful. It has a range of just over 2 meters, and it's usually quite accurate within 1 or 2 centimeters, even at that range. Also here on the side, there's what appears to be an arm. This is a sound sensor, so this will measure how loud things are. Unfortunately, I don't know whether or not it's possible or practical to do voice recognition through this. I haven't explored this myself yet. And on the bottom, there is a light sensor, and the light sensor can be used to detect whether or not there's a bright area or a dark area. And one of the most popular things for this light sensor is actually have it pointed down at the ground so that it can follow lines. So if you wanted to tape out a dark path showing a robot where to drive, it could actually detect as it goes. And
how do students interact with this? Do they like the fact that they can really move robots by themselves, or do they get frustrated at times? And
It's a little bit of both. The easy answer to this is most students who interact with the robots have an awful lot of fun with it, because when you make a mistake, the robot will usually do something silly, and it's usually quite entertaining. So the robots may flip over. We saw some examples here today. The robots may crash into each other. Sometimes something just may make a really strange sound. So they do have a lot of fun with it.
Okay.
There are some frustrations with it because, of course, you're dealing with real life. Some of these things, such as the sound sensor, this is an instantaneous measurement. So if there's not sound going at exactly the time that you read the sound measurement, you may not hear anything. So if somebody's clapping one clap at a time, if it reads when the person isn't clapping their hand, because it's between claps, they may not hear it.
Okay.
When they're dealing with the light sensor, sometimes we use the light sensor to detect certain colors, but it's simply it's like watching a black and white television set. You have different shades of gray, and sometimes green and blue might look almost exactly the same. And sometimes the students get frustrated with this because they will run the program once, and if the light is just a little bit different, it may run differently the next time. So it can take a little bit of explanation before the students start, so that they don't become too frustrated with this.
Okay.
But for very basic movements and measuring distance of things, usually the robot is quite accurate, and it's well received.
Okay. So can you show us a movement?
Sure.
And tell us, about the software you use.
Now, there are several options for writing programs on the Lego Mindstorm robot.
Okay.
People have developed environments for using traditional programming languages such as Java and C++ and other languages that are very similar to these.
Okay.
What we are using in our current preparatory program is something called the NXT-G programming language, and this is provided by Lego. It comes with the kit, and what it simulates the construction of programs using a flowchart. It's a very easy to use programming language, but unfortunately, as a result of being really easy to use, it is somewhat limited, especially when you start getting into things such as variables. Okay? However, what we will do is I can show you some very simple movements here today in order to get an idea of what's involved. And what we'll do is we'll start off with, maybe we'll do two programs?
Sure, that would be great.
We'll do a very simple program where the robot will go forward a certain distance, and maybe we'll have it run some small pattern, like turn left and right, and then come back to where it started.
Yeah, that would be great.
And then afterwards, we'll try using one of these sensors, so you can see how this
That would be
looks.
really good.
Okay, this is what the programming language looks like, or what the programming environment looks like. And you'll see here, this is where the start begins.
Okay.
And simply, all that we do is we drag over blocks as we require, and they go from left to right, just as the way how a traditional flowchart would go from top to bottom.
Okay.
Okay. So what I'm going to do, if we want the robot to say go forward, turn 90 degrees, go forward, turn 90 degrees, and go forward, what we can do is we could bring over a move block. Okay. And you'll see here, if you want to move in a little bit closer so you can see what's happening.
I'm zooming.
Okay. You'll see here that this move block is currently set up to operate both the C and B motors at the same time.
Yes.
And if you recall, that's what my robot is set up to, is for both the C and B motors. And what we'll do is we'll let the robot go forward we can set how long the robot's going to turn on its motors for by the number of rotations of the wheels.
Okay.
Or we have some other options here. We can say turn on the motors for so many seconds, or we can ask it to turn on the motors for so many degrees, and of course 360 degrees being one full rotation.
Okay.
So I think for fun this time what we'll do is we'll let it run for 3 rotations.
Okay.
So that means that these wheels are going to turn on, and they're going to turn completely around 3 times and then stop.
Okay.
Okay?
Great.
So this will make the robot go forward. Some of the other options that we can also have the robot go backwards. We can use some steering to make it go to the left or right. I found that these are not highly accurate. It is possible to use it, but sometimes you won't get the robot going exactly where you want without a lot of fiddling around. But we do have some options. We can make the speed of the robot change. So I think what we'll do is we'll slow this down. And of course, it's just like driving a car. If you drive your car too fast, you're going to have difficulty stopping.
Yeah.
You're going to have difficulty making corners, but of course, you'll get there sooner.
Yeah.
Okay? So it all has to do with accuracy. And what we'll do is we'll try one at 25, we'll try one at 50, and we'll try one at 100.
Okay.
Okay, so what we're going to do is we're going to make the robot
Three.
go forward 3 rotations, and then what we're going to do is we're going to bring over another move block, but this time, rather than running both the B and C motors, I'm going to run just the B motor. And of course, what will happen is if just the B motor turns, the robot will turn. Now, if I turn the robot, if I turn on the B motor, and I'm going to run this at exactly the same speed at 25, if I was to make the B motor run for 1 full rotation, I believe that this will get us very close to a 90-degree turn. It won't be exact because it has a lot to do with how far the wheels are spaced. For example, if I move these wheels apart a little bit further, then suddenly the turning radius has changed very much.
Okay.
But this will be very close to making a 90-degree
90
turn.
degrees, okay.
And even if not, we'll have to live with this.
Okay.
All right, so this will make it turn about 90 degrees. And let's bring over another move block. And again, this time we'll use the C and B motors. And we'll let this run for another 3 rotations. Okay, this time we'll let the motor run at we'll set it to 50%, so half speed. Okay, and then once we're finished this, we'll just toss in another, maybe this time we'll turn on the C motor, so the robot should turn the other direction. And again, we'll let it run 1 rotation. And what this should do is it should now be pointing back roughly the same direction as where it was, the same direction it started. And then what we'll do is we will move the robot backwards. So I'll select the backwards direction. We'll run both motors. We'll run 3 rotations, but this time we'll try and see what full speed looks like.
Okay. Great.
That's all that's involved with writing very simple movement programs. It's just one after another.
So there is no coding required, right?
There's no coding required. This is the coding.
Okay.
Now, of course, what happens is when you ask this program to be put onto the computer, this program will be turned into machine code for the interpreter to run on the brick. Okay, but the actual programmer doesn't need to deal with any of the syntax. That is
Okay.
one of the positives of this language. So in order to download this, what I will need to do is I'll need to start up the NXT robot. So we'll switch this on and let this boot up. Okay, so this is now booted up. So now downloading the program turns out to be very easy. Here, the program is called Test3, so let's keep that in mind. And we'll click on this button here to download. And if all goes well, okay,
Great.
one beep is good. Okay, now that we've downloaded the program, now we can run the program as many times as we want. So what I'll do is I'll take this off, and we'll try running this one on the floor, I think.
Okay.
Okay, because I'm not sure how far this is going to go.
Okay.
So we'll put it down onto the floor, and we will simply run the program.
Okay.
So what I need to do is I need to find the program here. So if you want to look at this first,
Yeah.
just to see what the screen
I'm
looks like.
zooming.
Okay. You'll see here it says My Files. So I'm going to select My Files.
Yeah.
These are the software files, so select here. And you'll see this is called Test3. So that's the program that we just downloaded.
Okay.
So I'll point it this way, and I'll select this, and I'll say, yes, I'd like to go ahead and run this. So what this should do is it should go forward, it should turn 90 degrees.
Okay.
It should go forward, it should turn 90 degrees, and it should come back.
All of that. Okay.
That's what we put in here.
Okay.
Yeah, that should be what happens.
So should we remove the chair first? Or it doesn't?
Maybe move the chair.
Okay.
Okay.
Thank you.
Okay, so we'll let this run and see what happens. Okay, so there's our first movement. It's going to go 3 rotations. It's going fairly slow. That was at 25% of the maximum speed. Okay, and there's one of the motors. That was the B motor only. Here's our turn. It's going to do 3 rotations. It will now make the final turn. Oh, and then back up.
Back. Okay.
Okay, there we go. And that's
Yeah.
that's a basic maneuvering operation. So what you could do with this is you could set up an obstacle course, have the students actually go try to avoid an object, and what you could do is you can measure, let them know how big the pathways are, and actually have them follow. There is some issues with this because unfortunately the robot does have difficulty going in a straight line. It depends upon the quality of the build. And also making a 90-degree turn can sometimes be somewhat difficult. And even two robots that are built by two different groups may behave just slightly differently because of the spacing of the wheels and how much drag is being added. But as long as they know in advance, it's usually fine. So this is typically one of the first programs that we would have the students do, is provide them some kind of an obstacle course to avoid an object at a known location. Okay? Now, if we wanted to do something where we didn't know what the environment looks like, maybe we'll try using the ultrasonic sensor.
Okay.
And I see I've got a box over on the table. And what we'll do is this time we'll have the robot go forward until it gets a certain distance away from the box. And
Okay.
maybe what we'll do, for fun, we'll try spinning the arm around a couple of times.
All right,
to see
yeah,
what
that would
happens.
be...
Okay?
Okay.
But of course, what we're going to do is we're going to wait until we get up to the box, and then we'll try hitting something.
Okay.
I wonder if I dare try to hit something. Maybe we wouldn't try to hit something, but we'll stop, we'll spin the arm around.
Okay.
So maybe you can imagine that there would be a soccer ball at the, up
Yeah.
close to the box.
Okay.
Okay, so this time, what I'm going to do is, I'm going to take all of this program and erase it. Okay, so
Okay.
it's gone, and we'll start a new program from scratch. This time, it's almost the same idea. We're going to turn on a move block so that the robot can start going forward. But this time, I don't know how far away the box is going to be. So what I'm going to do is I'm going to use this option here called Unlimited, which simply turns the motor on, and it leaves it on.
Okay.
Okay, and 75 is a reasonable speed. It's somewhat controllable. Okay, it could be a little bit slower, but
Okay.
we'll have some fun and watch it go faster. But then what we're going to do is I'm going to introduce this thing here called a wait block, because when you turn the motors on, it immediately goes to the next block. So you can imagine, as before we said move the robot forward 3 rotations, what it does is the program waits here until all 3 rotations are done, then goes forward. So this time what we're going to do is we're going to introduce this wait block. So this first of all turns on the motors, and then it waits here. And of course, I'm not interested in waiting for somebody to touch the robot.
Okay.
I'm waiting for something called the ultrasonic sensor, which is the thing that looks like a pair of eyes, to measure a distance. And we're going to set this up to 30 centimeters is fairly reasonable. So when the robot reaches 30 centimeters away from this point right here, not here, because this is where the sensor is, then the rest of the program will continue. And what I'm going to do is I'm going to use a move block, and I'm going to simply stop the motor. So this turns the motors off. So once we reach 30 centimeters from the box, we're going to turn the motor off. And, well, let's do one more thing. Let's add another wait block. But this time, I'm going to wait on time. So what we'll do is we'll wait for 1 second. So we'll let one entire second elapse. And then what I'll do is I'll bring over another motor block here, but this time we'll try the A motor block, which, if you recall, I fixed the motor block earlier so that this arm is connected to motor block A. And I don't think we want to turn it on limited, but let's turn it on for 1 rotation. So this should cause this part here to turn a full rotation. Now, of course, when this turns a full rotation, this may actually cause the actual swinging arm to turn around several times, but that's okay.
Okay.
Okay, and you see it's also going to wait for completion, and of course I can spin this as fast as we can. Well, if we're trying to hit a football, we would probably want to turn this up as fast as we can. So we'll see how fast the thing can actually spin. I'm not sure. I don't think I've tried this before. But
Let's
This
do it.
is entertainment. And of course, once this is finished, then that's the end of the program. And
Okay.
That's it. Okay, let's try downloading this. Okay, again, that's a good sign. Now, of course, comes the moment of truth that we actually managed to write the program so it will work. Okay, so you see here, remember that we had no idea how far away the robot was from the box. So again, what we'll do is we'll start this up. One of the problems, of course, is starting this when we're measuring the ultrasonic sensor is quite often a lot of people, students and participants in conferences, will stick their hand in front of it, but of course that measures the distance and immediately stops the robot. So unfortunately what I had to do is I had to stick my finger over here to the side so I don't get in front of the sensor. Okay, so good so far. Now if it stops, there we go, and that's it.
Yeah.
Yeah, so should we try that again?
Yeah.
Okay, well here. Let's see, there's a red ball.
Okay.
Okay, so let's put the red ball actually that far away, huh? No,
Okay.
okay, so we say about 30 centimeters. see if this will be a good test. Okay, well, that's going to be fairly close to 30 centimeters. So let's see. So there's a 30 centimeters. There's where the ball is. Oh, I'm going to have a problem. I'm going to run over this thing. Maybe we better come back here just a little bit. So it's almost the same distance as before. Okay, so that's about 30 centimeters out. We'll put the ball here. And we'll see whether or not we can actually hit it.
Yeah.
Okay, so this time we'll start it this way. One of the most difficult things is actually getting the robot aligned so it goes forward in the right direction. So we'll see. You never know, it might work, but at least we'll see it happen.
Okay.
In fact, we'll move it a little bit closer to show you that I haven't pre-programmed where the sensor for this is. It actually is using the distance sensor. So we'll give this a try.
All right.
Okay. Oh, it bumped into it, so it missed.
Yeah.
Yeah.
It didn't sense it then.
It didn't sense that because you see where the ultrasonic sensor is looking for. The ultrasonic sensor is looking for this. Right? So unfortunately, it went a little too far. So if you want to try again, we can back it up and try one final time. And maybe it'll stop soon enough.
Ah.
Yeah, not quite long enough.
But that was better than the last time.
Yeah, it was better than last time.
Yeah. Thank you so
Okay.
much for this
No
lovely
problem.
demonstration.
Yeah.
And we hope people know more about robotics and we raise awareness about this issue. Thanks a lot.
Okay, thank you.